Hello students, welcome to this session of materials, metals and non-metals. In the previous session, we discussed about the physical properties of metals and non-metals. See, here also you can see these are all metals. These are the ores of metals from where the metals are extracted. Right? I hope you are through with the properties, the physical properties of metals and non-metals. Now let's discuss about the chemical properties of metals and non-metals. First of all, tell me, what do you mean by chemical properties? Chemical, as the word indicates, it relates to the chemical reactions. The reactions which these metals and non-metals they undergo. Say for example, oxygen. Oxygen is a non-metal. Hydrogen is again a non-metal. They both react and they form what? Water. Water is a compound. Right? Elements, they combine and they form what? Compounds. So this chemical combination, this combination of elements is called as its chemical property, right? Like carbon. Carbon may exist as coal, coke. It may exist as diamond also. It may exist as graphite. So the reaction of carbon with oxygen leads to the formation of carbon dioxide, which is a gas. Carbon is solid. See, carbon normally reacts in the graphite form, right? Carbon solid, that is the graphite. It reacts with oxygen on heating, of course. So it is heated, and on heating it forms what? Carbon dioxide, which is a gas, right? So in this session, we are going to discuss about the chemical properties of metals and non-metals. About the reaction of metals with different elements. Say metals with oxygen and also the non-metals with oxygen. How they react. How metals react with water and how non-metals react with water. What are the compounds formed when metals and non-metals react with water? So let's start our session here. Reaction of metals and non-metals with oxygen. Let's first see how the metals react with oxygen. Right? How they react. What is the product formed when the metals react with oxygen? Reacts are simply the chemical combination. Metals react with oxygen producing respective oxides. The compound formed on the reaction of metal with oxygen is called as oxide. Right? See, metals like sodium and potassium are some of the most reactive metals. These are the metals. Though they are very soft, they are the exceptions. Right? We have discussed that the metals are hard. They are sonorous. They are lustrous. But sodium and potassium are exceptions. They are soft metals and they can be cut with a knife. Sodium metal reacts with the oxygen of air at room temperature to form sodium oxide. Sodium oxide, right? So it reacts with oxygen at room temperature, forming sodium oxide. The reaction is vigorous. Vigorous means it explodes or it catches fire. Right? It is vigorous. Hence, sodium is stored under kerosene to prevent its reaction with oxygen, moisture, and even with carbon dioxide. As sodium is highly reactive, it reacts with the moisture content of the air, moisture that is water vapor present in the air. Carbon dioxide present in the air and even with the oxygen. And the reaction is vigorous. Vigorous, that is, it large amount of energy is liberated. And what will be the form of energy? It is liberated in the form of heat. It catches fire. Say sodium, it reacts with oxygen. The symbol of sodium is Na. You must have studied in your previous class. Na stands for natrium. Natrium is the Latin name of sodium and Na is the symbol. Oxygen. Oxygen is O2. Oxygen exists as diatomic molecule, that is like this. This also you must have studied. These two combine and they form what? Sodium oxide. Okay? As sodium is highly reactive, it combines with oxygen and the reaction is vigorous. It proceeds with the liberation or with the release of lots of energy. Energy in the form of heat energy. Right? So, sodium when exposed to air catches fire. So, this is the product formed. The next is rusting of iron is also the example of this, the reaction of metal with oxygen. Burning of magnesium ribbon in air. In both these processes, oxides are formed. Magnesium on heating burns in air with dazzling white light, forming magnesium oxide. See, magnesium, when it is heated, it burns. Right, with a dazzling white light. It means what is happening? Magnesium is reacting with oxygen and forming a compound known as magnesium oxide. Right? And a lot of energy is released and in the form of light. Likewise, other metals also react with oxygen, producing their respective oxides. Iron also reacts with oxygen. Copper also reacts with oxygen and they form their respective compounds. They forming different, say iron is forming iron oxide on reacting with oxygen. We are going to discuss about a very interesting phenomenon known as rusting or corrosion, I can say. A very interesting phenomenon, that is corrosion. What is it? Let's see it. What is corrosion? The process of slow eating of a metal. The process of slow eating away of a metal due to the attack of atmospheric gases and moisture on its surface is called corrosion. See, these are the iron nails, which when exposed to the moisture, there is a brown colored substance accumulated on it. Likewise, this is an iron, say a part of a iron bridge on which rust has been accumulated. Now this brown colored substance which is formed is called as rust. How this is formed? Iron, this is a metal, reacts with the oxygen present in the atmosphere and water. See, the water gets accumulated. See, on the exposed iron objects, there will be water also. So these three react together and they form a compound called as ferric oxide. This is hydrated ferric oxide. You must have seen this rust is in the form of brown powder, powdered form that can be scratched from the surface. Say if this particular sheet is scratched, the rust or that brown powder will go off and a fresh piece of iron will be exposed to the atmosphere. That again will also get rusted. Right? So that will lead to what? That will lead to a, say, hole in this bridge. That iron is eaten up. Right? So this is slow eating away of a metal. that iron, whatever is present, say if it is a fresh block of iron or fresh sheet of iron, on the surface of the sheet, iron atoms or iron particles will be there. These iron particles will react with oxygen and water and they'll form hydrated ferric oxide. In which form it is? It is in the form of reddish powder, which can be scratched off, and the fresh metal is exposed. Right? So this is how rusting takes place, or the corrosion of iron takes place. In order to protect iron from getting corroded, what is done? It is painted. So if you paint the surface of iron or paint an iron object, what are you doing it by painting it? Say if this iron object is painted, what will happen? The surface will be protected. It will not be exposed to oxygen and moisture or to the atmosphere. So it will not get corroded. And iron will be protected. Right? So this is what is rust on iron object or corrosion. We can protect the iron objects by painting them. Right? Likewise, copper vessel also gets corroded. Copper also gets corroded. How? When a copper vessel is exposed to moist air, it acquires a dull green coating. Right? This green material formed is a mixture of copper hydroxide and copper carbonate. You must have seen copper vessels at your home. See, if you keep it as such for, say, even for 2 or 3 days, they acquire a green coating over them. That is again the rust. That is the corrosion of copper. How that particular green material is formed? It is formed by the reaction of copper with water and carbon dioxide and also the oxygen present in the air, forming copper hydroxide and copper carbonate. So copper reacts with water, carbon dioxide and oxygen, forming copper hydroxide and copper carbonate. So this is the green mixture or green material which is formed on the surface of copper. This can be also scratched off, but you can't scratch it with a cloth or with a scrubber. There is a compound required to just remove this material off. Right? You must have heard about pitambari, which is used to remove this compound, which is formed on the surface. Or a small amount of tamarind can also remove this base or remove this material. Right? If it is scrubbed with the tamarind, that can also remove this material. So this is what is corrosion or rusting. Now I've got a very interesting question, or a question that, say, the water pipelines, they are made up of iron. Right? The pipelines which bring water to home, they are all made up of iron. Right? So iron will get rusted here. Iron will get corroded from inside. Right? And what will happen? We'll get iron particles in the form of rust. And slowly what will happen? This iron pipeline will get dissolved. But it doesn't happen. Why so? Because the iron pipelines or iron is coated with zinc in order to protect it from getting corroded. Right? In order to protect it from corrosion. Fine. Now this process of coating iron with zinc is called as galvanization, or is known as galvanization. Do remember this, right? This can be a question, that the iron pipelines are used for supplying water, still it doesn't get corroded. Why? This is because that iron over there, or the iron pipes, they are coated with zinc in order to protect it from corrosion, right? And this process of coating iron with zinc is called as galvanization. Okay. Now let's see what is the nature of these oxides or the hydroxides formed. What is the nature? Are they acidic or are they basic? What is the test for the acidic or basic nature of a substance? It's the litmus test. Acids turn blue litmus red, and bases turn red litmus blue. That is a litmus test. So let's do the litmus test and find out what is the nature of these oxides of metals. How can we test the nature of metal oxides, whether they are basic or acidic? By dissolving these oxides in water and testing it with litmus paper. So say let's talk of the magnesium oxide, which is formed by burning magnesium ribbon in air, right? What is done is, the ash obtained on burning magnesium ribbon is dissolved in water, right? And is tested with litmus paper. In the acidic solution, what happens? Blue litmus turns to red. Whereas in the basic solution, what happens? Red litmus turns to blue, right? So when the ash of magnesium oxide, or when the ash obtained on burning magnesium ribbon is dissolved in water and tested with litmus paper, it is found that it is basic in nature, right? See here, the solution, this is the magnesium solution, the magnesium hydroxide. Say the magnesium oxide which is formed reacts with water, forming magnesium hydroxide. This magnesium hydroxide is basic. This is a red litmus paper, and the solution is turning red litmus paper blue. So what is formed after magnesium oxide is dissolved in water? The compound formed is magnesium hydroxide, right? And remember, all the metal oxides are basic in nature. When these oxides are dissolved in water, they form their respective hydroxides. And so metal oxides are basic in nature and they turn red litmus blue. Okay? See, this is a litmus test for iron suspension, or this rust suspension. This is not iron, this is rust suspension. Rust, which is formed on the surface of iron, is dissolved in water, forming the rust suspension. Suspension means the particles are not completely dissolved in water. You can see the particles, right? See, this is the rust. This rust is dissolved in water, taken in this test tube. Then water is taken, then this rust suspension is taken in a plate and it is tested with red litmus paper. This red litmus paper turned blue. It indicates that rust consists of a substance which is basic in nature. Because bases turn red litmus blue, right? So what is rust consisting of? It is consisting of ferric oxide and XH2O. This rust, when is dissolved in water, or when it is dissolved in water, it forms a rust suspension. The compound formed here is ferric hydroxide, right? This ferric oxide reacts with water, forming ferric hydroxide. And this ferric hydroxide is basic in nature. So what compound is present in this suspension? It is ferric hydroxide, right? So what type of oxides are formed by the metals? Metals form basic oxides. Metals form basic oxides. This is one of the property of metals, the chemical property of metal. Now let's see what type of oxides are formed by nonmetals. Nonmetals react with oxygen, forming nonmetal oxides. These oxides are acidic or neutral in nature. These oxides are acidic means these oxides are acidic or neutral. Acidic means, see, acids turn blue litmus red. Acids turn blue litmus red, right? And bases turn red litmus blue. See, sulfur. Sulfur is a non-metal, right? It is not sonorous, it is not ductile, it is not malleable, it is a poor conductor, it is a bad conductor of electricity and heat. When it reacts with oxygen, it forms sulfur dioxide. This is di. See, 2 is here, right? Sulfur, S for sulfur, O for oxygen, and the name is oxide. And as it is 2 here, so it is named as sulfur dioxide. Carbon with oxygen forms carbon dioxide. It is also acidic oxide. Whereas hydrogen reacts with oxygen forming water, and water is neutral. See, water has no effect on litmus paper. Litmus paper, when neutral, is purple in color. So water doesn't change the color of litmus paper, right? How we will test these oxides, the acidic or the basic nature of oxides? Say these oxides dissolved. These oxides are dissolved in water to form acids, or these oxides dissolve in water. It should be these oxides dissolve in water to form acids, right? So these oxides, a carbon dioxide with water forms carbonic acid. Sulfur dioxide with water forms sulfurous acid, right? These are all acids. Whereas your metal oxides like magnesium oxide, it dissolves in water forming what? Magnesium hydroxide. Ferric oxide, which is rust, Fe2O3, it dissolves in water forming what? Ferric hydroxide. Whereas the carbon dioxide, sulfur dioxide, they dissolve in water forming carbonic acid, forming sulfurous acids. Right? So this is the difference between the metals and non-metals in their reaction with oxygen, right? Metals form basic oxides. Their solution in water, the solution of oxides in water, turn red litmus blue. Whereas non-metals form acidic oxides, their solution, that is solution of oxides of non-metals in water, turns blue litmus red. Right? So this is how the metals and the non-metals, they differ from each other in their chemical reactions. I hope you have understood these reactions. Now I'll be concluding this session. In the next session, we'll be discussing about the reaction of metals and non-metals with water. Right? What are the products formed when a metal reacts with water and a non-metal reacts with water? Right? You're seeing these reaction equations for the first time, I suppose. No, you must have done it in your grade 7 also. So don't get horrified. These are very simple equations and don't try to mug up the things. Just try to remember the products which are formed. Right? Then only you can write the equation for it. So do remember, metals react with oxygen producing basic oxides and non-metals react with oxygen producing acidic oxides. How to test the nature of oxides? By dissolving them in water. The solution of metal oxides in water turns red litmus blue, whereas the solution of non-metal oxides in water turns blue litmus red. That's it. It's so simple. Just go through your text, just read these equations again so that you are through with it. Right? So thank you students for listening patiently and do have a nice time ahead.